I'm sorry. This one's really funny. I'm sorry I don't have it on the floor to show you. It goes everywhere and it bumps into a wall and it keeps going. Anyway, this was one of my mom's old wind-up toys. But you know what? We're talking about parallel and perpendicular, and you can find it everywhere. I found it in this toy. See the little wheels? They're parallel to each other. This wouldn't work so well if they weren't. And the little turn key here to wind it up, it has a perpendicular relationship. So this part is perpendicular to the part that goes into the little mechanism that makes this little frog go. Anyway, so, sometimes you just feel like your wheels are spinning. But if you, put your foot down, you can go places. All right. Say bye-bye to the frog. Say bye-bye, frog. All right. So, we're going to take a look at parallel and perpendicular. And you know what? Yes, this is review. Because we have discussed parallel and perpendicular before. We know parallel lines that don't intersect, right? And we also know as far as when you're looking at the equations, the slopes will be the same, but they will have a different y-intercept. So if you were looking at it and we said, okay, the slope is 3/4 for the original line. Well, for the new parallel line, the parallel slope would be, wait for it, it would still be 3/4. But with that different y-intercept, it's going to be a different line. All right, so if we were looking at this and they gave us this line, this is all deja vu, people. I'm given this line. It's parallel to this one, but it's going to be going through this new point of 1, 4. What's the equation going to be for the new line? So we have choices. One choice would be to use point slope. That point slope form, y minus y1 is equal to slope times x minus x1. So let's try that one. I'm going to say y minus, and the y1 value would be 4. And we know our slope, our parallel slope, is still going to be 1/2. It's not going to change from the original line. So I'm going to put 1/2 in here. We know that guy. So then I'm going to put that x1 in here. And then we'll do our distributive, 1/2 x minus 1/2, and then we'll add 4 to both sides. So then we're going to end up with, let's see, negative 1/2 plus 4. It'll end up being a 3.5. So there's one way, using that point slope. Or we could use slope-intercept form and plug in everything we know. Well, we don't know what the new y-intercept is going to be, but we do know an x and a y, and we do know the slope. So let's plug them in. So I'm going to put a 4 here. I'm going to put a 1/2 here. I'm going to replace that x with that 1. And then I'm just going to solve for b. 1/2 times 1, which is 1/2. I subtract 1/2 from both sides. b is equal to, wait for it, 3.5. And then we plug that into our new equation. So guess what? No matter which way you do it, you're going to end up with your new y-intercept of 3.5, and your slope would be 1/2. All right, so perpendicular, we know it's a little different. It's a little different. Lines that intersect and make that 90-degree angle. And they do have a relationship with their slopes that are opposite reciprocals. So, for instance, let's say I gave you, like we did over here, I said the slope was 3/4. And I said, hey, what is the perpendicular slope going to be? Opposite reciprocal. So I'm going to flip it and reverse the sign. So it would be negative 4/3. All right, well, what if it was something a little tricky, like your slope was -1, and I wanted to know the perpendicular slope? Anybody? 1 is really 1/1, and you flip it and reverse it, and guess what? It's going to be 1. All right, now what if it was something even trickier? What if the slope was 0? What would the perpendicular slope be? Might have to draw myself a Dollar Tree graph. Okay, if the slope is 0 and it's perpendicular, it's going to be undefined. Haven't seen that guy in a while, have we? All right, so before we start trying to find this new equation, we know that the given slope here is 1/2. So that means my perpendicular slope is going to be opposite reciprocal, -2. I don't like to say negative reciprocal because if you start off with a negative, then your new slope is not going to be negative. So let's stick with that terminology of opposite. All right, so I know that my new slope of my line, and I'm going to start backwards. I'm going to start with this one, the y is equal to mx plus b. I already know that my new slope is going to be -2. And really all I need to do is solve for that y-intercept. So I'm going to replace the x and the y with the ordered pair that they gave me and solve for the b. So I'm going to replace the y with a -6 and the x with a 2. And I'm going to solve. All right, there we go. So there's one way to find our answer. Our answer is going to be y is equal to -2x, and our new y-intercept is -2. So that's one way, and we could have also used the point slope. Doesn't matter. You can use either method that you want. So I'm going to go with the point slope. It would be y minus -6, so obviously that's going to flip. I'm going to stay with that slope, and then x minus the 2. So I do my distributive. Careful with those negatives. And then I'm going to do this. Well, look at there. That looks kind of familiar, doesn't it? All right, very good. So either way it's going to work. Okay, so let's flip over here. Let's take a look at what's going on back here. They gave us some examples, and I want to remind you, don't forget that if an equation is in standard form, we can use this little guy to help us out. Remember, that's a lazy mathematician. That's one of their favorite little tricks to use. I say they, you know it's me. What is the slope of all lines parallel to this guy? All right, so is he in standard form? Yes, he is. So that means I'm going to use my little trick of -a over b. A is 1, b is 2. So that would be a -1 over a +2. So guess what? You are correct. It's going to be b. Oop, you know what? And I'm going to highlight this because this is going to go back and forth between parallel and perpendicular. I want to make sure I'm finding the right thing. So on number 2, I'm looking for the slope of all lines that are parallel to this guy. Okay, well, look at us. Lucky, it's in standard form again. So I'm going to do my little trick. Opposite of A over the B. What's that going to simplify to? I think it's going to simplify to 3. So what's the slope going to be for any line parallel to this guy? It's going to be 3. You are correct. All right, now, changing gears. On this one, they're looking for a perpendicular relationship. Well, this one is in standard form, so we can use our little trick to find our original slope. So that would be, let's see, a -2 over -5. So my original slope is 2/5. Now the question is, what's my perpendicular slope going to be? Opposite reciprocal. All right, you got to flip and reverse that sign. So if you were thinking C, you were thinking right. Okay, look at number 4. Again, it's perpendicular. Oof, what is this mess that they gave us? We're going to have to, probably I would recommend putting this into, let's go ahead and put it in slope intercept. So we're going to do our distributive property first. So I've got 3y minus 12. And then I'm going to move that 12 over. So now I have, what do I have? I've got 3y is equal to negative 9x plus 12. And then I need to get the y by itself. All right, there we go. So there's our slope. There's the slope of the line that they gave us. That's the original slope, but we want the perpendicular slope. Opposite reciprocal of negative 3. I'm going to go ahead and put it over 1 just to remind our brain what's going to happen when it flips. So that's going to give us a 1/3. All right, do we see it here? Yep, there it is. All right, which of the following best describe, x is equal to 2 and y is equal to negative 3. No, pardon, y is equal to 3. Who's thinking Dollar Tree graph? Well, guess what? You are correct. So let's put in a Dollar Tree graph. Let's see. X is equal to 2. That's going to be this vertical line. Y is equal to 3. That's going to be this horizontal line. Which of the following best? Okay, so here's the thing. Best describes this relationship. Well, I can see clearly that they're intersecting. So that's true. And I can also see that they are perpendicular. That's true. But if I was going to say best, I probably would go with perpendicular. I would say this one is okay, but I would say this guy would be the best. Okay? All right. And last but not least, they want you to determine the relationships going on between these sets of equations. So they want us to define if it's parallel, perpendicular, or neither. So really, all we need to do is hunt down the slopes and then make that decision. So let's take a look at A here. What's the slope for this one? Well, it's going to be negative 1. And the slope for the second equation, that's going to be a 1. So what kind of relationship's going on between that negative 1 and that 1? You're thinking perpendicular. You should be thinking perpendicular. That is correct. Let's see. Well, this one's not exactly in standard form, but if I did the negative a over the b, which would be negative 6 over 2. So this one, the slope's going to be negative 3. And, oh, look at that one. That one, the slope is negative 3. So guess what? What are you thinking? Yep, parallel. And then for C, some rude person wrote on top of that. Look at C. And again, it's not quite in standard form. If I rearranged it a little bit, it would be. And so I could find that slope real easily. So that would be what? The opposite of A. So that would be a positive 12 over the 6. Oh, there it is. It's 2. Okay, so for the first one, the slope's going to be 2. And this one, not in slope intercept, but we're going to move that 2x to the other side. Oh, okay, so what kind of relationship could be described with these two slopes where one is 2 and one is negative 2? Are they parallel? Nope. Are they perpendicular? Is negative 2 the opposite reciprocal of 2? No. So that one would be neither. All right. Fantastic. You did a great job. All right. Keep in mind, you always got to keep your feet on the ground. Okay. See y'all later, peeps.